Hello everyone. Welcome back to another episode of Science Genius. Today, we will be looking at atom and atomic structure, so let's get started. So, at first, what is an atom? The atom is the fundamental unit of matter. It consists of a central nucleus containing positively charged protons and neutral neutrons, surrounded by a cloud of negatively charged electrons. The arrangement of these subatomic particles in an atom determines its overall charge and behavior. Atoms combine to form molecules through chemical bonds, and the study of atoms and their interactions is fundamental to the understanding of chemistry. So, now let's see inside an atom. As I told before, the atom is composed of positively charged protons, negatively charged electrons and neutral subatomic particles called neutrons. The protons and neutrons together form the nucleus, and it is in the nucleus that most of the mass of an atom is concentrated. Going away from the nucleus, we can find the negatively charged electrons orbiting around the nucleus. The region where the electrons are mostly found is called the electron cloud. In quantum mechanics, particularly in the context of the Schrödinger equation, electrons are described in terms of wave functions. The wave function represents the probability amplitude of finding an electron at a particular position in space. The square of the modulus of this wave function gives the probability density of finding the electron at a specific location. The electron cloud is a visual representation of these probability densities. It is not a physical structure like a cloud in the sky, but rather a way to represent the likelihood of finding an electron in a particular region around the nucleus. The shape of the electron cloud is often depicted using three-dimensional models, and these shapes are referred to as atomic orbitals. Now let's look at particle-to-mass relationships. The proton-electron mass ratio, PEMR, indicates that protons and neutrons are much more massive than electrons in an atom. The electron's mass is negligible compared to that of protons and neutrons, predominantly determining atomic mass. PEMR influences chemical properties by affecting electron attraction to the nucleus, thereby influencing reactivity and chemical bonding. Now at last, let's look at electron configuration. The electronic configuration dictates how an atom interacts with others, influencing its ability to form chemical bonds and engage in reactions. The arrangement of electrons orbiting the nucleus is referred to as electronic configuration. The electron configuration of an atom describes how its electrons are distributed among the various atomic orbitals. It follows specific rules. Aufbau principle. Electrons fill the lowest energy orbitals first before moving to higher energy levels. Pauli exclusion principle. No two electrons in an atom can have the same set of 4 quantum numbers. This means that each orbital can hold a maximum of 2 electrons with opposite spins. Hund's rule. Electrons fill orbitals singly before pairing up. This maximizes the total spin, making the atom stable. That's all. Thanks for watching our video.